record this thing, then. Okay. So these are the few components of the computer system that we highlighted during the first um before the session actually dropped. So that is that. Now, as part of our discussion today, we are supposed to look at what data is. As programmers, I mean, some of us are already okay with basic stuff. Some of us too. Hey, who is that? Okay. So some of us are
Sorry,
okay. Some of us are already okay
I
with some
can't hear
basic
the
stuff.
sound word. That's why I put it in a distance. I connected
Okay.
wrong.
So can you hear me now?
Please, yes.
All right. Yeah. So like I said, as individuals or people who are aspiring to become programmers, we need to understand what data is, because when you are able to create your systems, when you're able to build your softwares, without data, your system is useless. Yes, without data, your system is useless. People need to use your system to feed it with data for you to see the progress of the system and even provide what we call maintenance and updates and all that. So data is very, very important when it comes to the concept of computers. So what then is data? Data refers to raw facts and figures that computers process to produce what we call meaningful information. Example include student's name. So in a class, when you have your students, when you have their names on paper or on record, that is a data. We have student scores. For instance, when an exam is conducted and you're able to record the scores of the individual students, that is also data. When population census is conducted, that is also data. All this data we have can be further manipulated to give us meaningful information. For instance, when you have students' name, you can decide to say, okay, out of the student's name, let me see those ones that have maybe common surnames. Probably. When you have student scores, you can decide to determine which student had the highest score, the total scores, the average student. So many things you can do with what? The student scores data. Population census too can give you a sense that, okay, we are anticipating that in the next 10 years, the population of Ghana can grow up to maybe 40 million or what have you, because we have a population census data currently. So that is what? A bit about data. Data is not only figures. Data is not only numbers, but it can also be images, it can be videos, it can be sound, what have you. Like, all those information are what? Data. Please note that. Note that. All right. Now, I did highlighted storage devices earlier, but then this is a separate slide that is talking a bit about what? Storage devices. So we've highlighted what a RAM is already. We are saying that it is a primary storage device for the computer. It is which stores data whenever an application is launched. It stores or loads that application into its memory and then causes the CPU to be able to access it and its instructions so that it'll be able to process it for you. So that is the RAM. We have secondary storage devices. We've said that those are able to store data for a longer period until maybe you decide to delete them, they are there. Or maybe it crashes or damages some way, somehow. Until then, those information are still kept on these secondary storage devices. Examples include hard disk drive, the flash memory, SD cards, etc., etc. So those are a bit about memory types. Memory and then memory types. All right, let's box on. Up to this point, we've said so many things already. We've talked about computers, what they are. We are saying that they are basic electronic devices that are able to what? Receive instructions and process them into meaningful information. How do they do that? They have certain components like the CPU, the storage devices, the input and output devices that act upon whatever instructions you are giving it to be able to process it into meaningful information. We've also said that computers are in various forms. It is not only the laptop or the desktop computers we see are the only devices that we regard as what computers. Your mobile phones, your smartwatches, even the analog ones, they are all computers. We've established all those facts already. Okay, now this is where the big deal starts. Instructions and then programming basics. Instructions, and programming. We've said that computers receive what we call instructions and then act on those instructions to give us meaning or provide meaningful information. What then is instruction, or what are instructions, and what is what programming? Let's continue. Any question up to this point? If not, let's finish. When you have questions, keep them. We will highlight them at the end of the session. So let's get to understand what instructions are. So we are saying instructions are commands. They are basically what? Commands that are given to computer to perform specific task. So computer instructions can be as simple as entering 2 plus 2 into a calculator for processing. So when you have your calculator and then you punch 2 and then plus and then another 2 and then hit equal, it gives you a result of 4. And that is a simple calculation that a calculator can do for you. Hello? Yeah, madam, deal with him. I'm okay. Please, can you give me 30 minutes? I'm currently having a Zoom session. Yeah.
Now he not crying on the TV, so I'll own mute. Oh.
Yes, so like I said, instructions or computer instructions can be as simple as what? Entering 2 plus 2 into a calculator for processing, and that is it. It gives you the result of 4, and that's all. It is a basic instruction. Now, we can also instruct the computer to perform complex what? Complex tasks or instructions for us. So for instance, when you go to google.com or yahoo.com and what have you, and then you search for maybe 7 ways of making money on the internet, there are so many information you are going to get. But then have you asked yourself how the system is able to process all those information and bring it to your doorstep for you to select and then read? The instructions that are going on behind whenever you enter 7 ways to make money online, that simple sentence, the instructions that underlines it for you to go and then search for all those information and bring it to you is not as simple as you might think. It is a very complex process. Yes, so like I said, instructions are just commands that we give to computers to perform a specific task. So for instance, when you enter 2 plus 2 into the calculator, that is an instruction, and it's a simple instruction. When you also go onto the internet and then you search maybe how to make money online as an instruction that you've given to the computer, the server or the internet will have to do complex searching of that information and bring you a result. And it is a complex process. So those are, that is basically what we can say or term instructions to what? To be. Now, let's look at programming languages. Before then, you ask yourself, how are the computers able to what? Understand the instructions that we give them? You pick your calculator and then you just punch 2 plus 2. Have you asked yourself how it is able to interpret 2 plus 2 and then give you the result to be 4? Have you asked yourself? Probably yes, probably no. They are done by the help of what we call programming languages. The instructions that we give to the computers for them to understand and then process and give us results, those instructions are able to get to the computer with the help of what we call programming languages. So when we talk about programming languages, these are languages that helps us write instructions for computers. Hello? Are we there?
Hello. Yes.
Yes.
We are here.
All right. So yes,
Yeah.
like I said,
Yeah, we are here.
yes. Good. Like I said, programming languages are basically languages that helps us write instructions for what? Computers. Already we've established what instructions are. These are just set of commands that we give to the computer to perform what? A specific task for us. But then when we enter 2 plus 2, how is the computer able to understand 2 plus 2? It is as a result of a programming language. So just like any other language that we speak, currently I'm speaking English and you are able to understand me because you also understand English. So for the computer, it understands what we call a programming language. It does, a bit of complications, or let's say a lot goes into the programming language before the instructions are understood. We will get into that as and when we progress. But for now, just understand that programming languages helps us to write instructions. The instructions can be simple, they can be complex for the computer. I have this nice diagram here. I believe you can see. These are images of various programming languages that we have. We have the C++. That is what we are going to be focusing on in our subsequent discussions. We have TypeScript. We have Python. We have R. We have Kotlin. We have C. We have C++. We have Java. We have PHP. We have, this is Ruby. And I think Ruby. There are so many of them. So many programming languages. And some are good at doing a particular thing. Others are also good at doing multifunctional, they are multi-purpose programming languages. So depending on your interest area, what you want to do would probably inform the language you will learn. So that is a bit about the programming language. Let's box on. So yes, so they are used to write instructions in a format that the computer can understand. We've established that already. So these are few examples of programming language that we have. We have JavaScript, we have C#, we have Python, C++, Pascal, we have Go, etc. Now, this is the takeaway, or this is what you have to notice. We have come to an era where we write instructions in what we call high-level language. We write instructions for the computer in high-level programming languages. But then computers do not understand high-level languages. They understand what we call machine language or machine codes, zeros and ones, binaries. Those are the instructions computers understand. So if, for instance, you are able to say, okay, print hello, and a computer is able to print or display that hello, have you asked yourself, how is the system able to understand print hello and then it's displaying hello for you to see? There are some tools or underlying factors that are able to pick that instruction, print hello, convert it into what we call binaries or machine code for the computer to understand and process, basically. And these underlying factors or tools that we are talking about are what we refer to as what? Compilers and interpreters. Are we there?
Yes.
Okay, so someone also sent a message right now. What is it saying? Okay. All right. Thank you for letting your people. That's fine. Yes. So, like I said, when you are able to write English-like statements, the high-level language means that languages that when you see, though it is not entirely English, it is not entirely making sense. But when I say print hello, when someone who understands English sees it, the person can infer that, okay, are you trying to maybe tell the computer to print hello? Someone who understands English can easily what? Infer that. But the computer doesn't understand that. So that print hello would have to be converted to zeros and ones, binaries, for it to understand. And that zeros and ones or binaries are what we refer to as machine code. And that is what the computers understand. Now, this is able to happen because of what we call compilers and interpreters. I've said that already. Compilers and interpreters, they do basically the same thing, but there is a little difference. Here is the
Please
difference.
excuse me.
Okay.
Yeah, the compiler is seen as the incorrect handler.
Please speak a bit louder. I can barely hear you.
Okay, you talk about compiler.
Uh-huh.
Is it seen as the incorrect handler, like something we understand that the computer don't understand and ABC or 1, 2, 3.
Okay, he doesn't
So the computer
understand it.
don't understand. Yes, it doesn't understand
Yeah.
characters and numbers.
Yes.
So we believe that the computer only understands zeros and one, which
Exactly.
are binary codes.
Exactly.
So we believe that there's a device within the computer that change binary codes to that change ABC to binary codes and give it to the computer. And also the computer give us a results of characters and numbers.
Yes.
Yeah. So the name of this device is said the interim handler or the compiler.
Okay.
That's what I'm looking for.
Good.
Was within the computer that change and ABC or 1, 2, 3 to binary codes in the split seconds and give us result, give the computer its result and give us our results as
Okay.
results.
Okay. Thank you for your question. So, it is not necessarily a device, but it is just a mechanism, or let's say a tool, or it is also another set of instructions. And that has been put together to do a particular thing. So one is the compiler and another is the interpreter. So look at the difference. The compiler, this is what it does. When you write your human or high-level language, which is maybe AMA, the computer would have to convert that AMA into binaries. So what will happen is the compiler.
I don't know. When we use our name right, when we use ASCII code write our names.
Don't
That's
worry.
it.
You will understand these things. You will appreciate why all those things are there. When you start to write the programs and then things are going on smoothly, you understand certain things, you appreciate all those things. So don't worry, we'll get there. Yes. So the compiler is able to pick your high-level language, which is maybe print hello or print goodbye. It picks that and then it compiles it down. It compiles it down to machine code for the computer to understand. But then the interpreter, what it does is it does not necessarily compile, but it is just a step away from what? The machine. So what happens is it is closer to machine code. The interpreter is much, much closer to what? The machine code. So when you say maybe print hello, that is a high level language. So interpreter cannot work over there. But then when you're able to say maybe
Please
I
excuse
need
me.
I didn't touch on a particular thing called assembly language. We have what we call assembly language. Now,
Please
assembly
excuse me.
languages. Hello?
Please excuse me.
Okay.
Yeah. Please make this instruction clear that everybody should turn off the microphone.
Oh, okay. People are
Wait,
talking
when
behind
you
it.
turn off the microphone, questions to say or what?
When you're about to ask question, you own it.
Okay, I hear.
So everybody should turn off the microphone because
All right. Thank you for that one. Yeah, so like I was saying, compiler goes through series of steps before it goes through series of steps before the computer is able to understand whatever instructions you are giving to it. But the interpreter is just like uh, maybe I'm speaking maybe English right now, and I want to translate that into maybe Spanish. The step is simple. Just pick whatever I'm saying. Give me what the Spanish version. But the compiler goes beyond that. It now has to convert that high level language into what we call assembly language. From assembly language before it goes to what machine code. So there are multiple steps when it comes to the compilation process, but interpreters does a little different than that, though they basically try to do the same thing, but that is the little difference. The compiler goes through more than 2 steps, while the interpreter goes through very few steps to what get the instructions to the computer to understand. Basically. All right. Yeah, so I have something here. So this is what an image that I captured. You look at the inscription here, it say what hello. Now this person here is going to interpret whatever is coming here to this person, and this person will now perceive it as what hello. And that is basically what the compiler and then the interpreter they try to do. They get a particular information from we the users or the programmers, and then they act upon that for the computer to understand, because this is what the computer understand. This person here we are saying is likened to what a computer who understand only binaries. Here this person understand only perhaps Spanish. So from English to Spanish there has to be an intermediary who cause this person to understand whatever we are saying. So that is basically the essence of the compiler and the interpreter. Okay. Yes. So up to this point, I believe we have consumed a lot already. I don't want to bore you so much with theories. Let's end here and then have some few questions. As we progress, we are going to be touching on essential stuffs like that. Yes.
Let's kill it today. Let's kill it all.
Yes. So kindly come up with if you have questions, come up with it. We try to share ideas and provide answers. If not to, let's move to look at the recap of this session and then look at what is next. Yes.
Yeah.
Mm-hmm.
So the ethical hacking,
Uh-huh.
does it come out of programming, or is it under programming?
Yes. I like how you are thinking. I can see that is your interest area, right?
Sure.
Yes.
oh,
Before
you
you're
guys
able to do ethical hacking, you have to know programming.
Okay.
Even if not ethical hacking or black hat hacking, which we call the they do the bad things. Basically, we say they do the bad things. You still have to know programming. Mind you,
All right.
it only becomes ethical when you get certificate and then work as a professional. That is why we term it as ethical. And that one you are giving permission before you try to what penetrate systems. But apart from that, when you don't get permission, that is where we term it as unethical. So in any of those, you have to know programming. Yes.
Okay.
Yes.
Thanks.
Any more question? Yeah, John,
So,
good luck. You've raised up your hand.
Yeah. Hello.
Yes, we are listening to you.
Okay, please. I want to get understanding of machine language, uh, and then high level language, and then the uh, assembly language, please.
Okay. So, note or listen carefully. The machine language is the
Okay.
binaries, zeros and ones, period. That is what the computer
Okay.
understands. But the assembly language is a little above the machine language. It's just a little above what? The machine language. The computer understands some part of it and does not understand some part of it. And assembly language is difficult for us, we programmers or humans, to be able to write. So some time back, some years ago, the earlier programmers, they were using assembly language to write instructions or write computer programs. But we have gotten past that stage where we are using what we call high-level language, like Python, like C++, like Java, to write instructions for the computer. So when you are using these modern languages, we are saying that you are using a high-level programming language to write instructions. Are we good?
Yeah, we are good.
Yeah, so that is basically the difference. So assembly language is in between the machine code and the human, the high level language. But machine language is the least one, which is the binaries, the zeros and one, and that is what the computer understands.
Okay, thank you.
All right. Any more questions? We have 10 minutes to drop.
Hello.
Yes. Anthony.
So
yes,
simply we
please.
can say that.
Anthony, you raised your hand. Yes.
Yeah, I have a question.
Yes. Let's listen to you.
So, let's talk about, for example, it's like about case studies,
Okay.
case study analysis and solution development.
Okay.
So, you talk about programming, and I heard something about case study, talk about analysis, you talk about solution, report presentation, and all of that. So I wanted to know, like, how do we use programming for problem solving skills and critical thinking
How
to
do we what?
analyze
How
them?
do we what? Come, speak a bit louder.
How can we use programming skills for problem solving? How can we use programming for problem
Okay.
solving skills
Okay.
and critical thinking to analyze the real world?
Okay. Okay. I like your
In
question.
a case study of logistics and propose a solution without using programming language.
Okay. Okay. I think I understand you up to a point. Now, what you have to understand is that when it comes to the world of engineering, it entails a lot. So when you are faced with a problem and then you want to use a programming approach to solve it, you have to go through series of steps. You have to go through series of steps. You have to do what we call requirement gathering. You have to do what we call system analysis. You have to collect a lot of data, which will give you informed what? Give you what? Yeah. Yeah.
What's one? What's one? Answer. Oh,
Yeah. So when you want to use programmatical approach to solve a problem, you would have to what? Go through series of steps. So I think in our next session, I'm going to give you, or I'm going to take you through what we call algorithms and how do you call it? Yes, I'll take you through what we call algorithms, okay? And that you get to understand how when you're faced with problem, you think through before you start writing code. So that is basically that. So don't worry. When you progress, you would understand or get to know more about how to what go about things. All right. When is the next meeting? Someone is asking. I believe it should be as soon as possible. Right now, you have few days to come back to school. It is already today is second. You have 23 days more. Yes.
Do the that's all.
Yes. Any more questions?
Hello, sir.
Yes. Yes.
Sir, please, I'm just asking the practical aspect,
Uh-huh.
Are we going to do it online or is it face to face?
Oh, the practical aspect, you guys suggested I record videos and then let you have it. So that is what I'm going to do. And then when I record the videos, you watch it and then you will discuss or suggest a date that we can meet online like so and then discuss it. And then probably when you guys come back from vacation to maybe we can continue from there in person. I mean face to face.
Okay, okay.
Yeah. Hold on a minute. Yes. Hello.
Hello, sir.
Yeah, any more questions?
So, sir, when is our next meeting? Is it tomorrow the same time?
Yes, what do you think?
I think. Okay.
What do you think? What do you think you're laughing?
Okay, they say let's make it the same time.
All right, hopefully. Any other?
Okay.
Okay, so I think if there are no more questions,
Ask question, we're listening. Knowledge.
Salifu, yes, you want to ask a question?
Hello, hello,
Yes.
sir. Please, good evening.
Evening.
Okay. Due to one or two reasons, like I couldn't find the meeting early, and I wanted to ask if maybe there's a recording ongoing.
Yes. So I think I'll share that with you when we are done.
All right.
All right.
Then thank you. Then after then I can
All right, sure.
also go to the.
Say, hope you add a slide to it.
Yes,
Okay.
I'll do that.
All right.
Okay.
Please excuse me, your name?
My name?
Yes, sir.
My name is Ernest.
Okay, Mr. Ernest.
Yes.
On behalf of my colleagues, I would like to appreciate you for your time and effort.
Okay.
So I'm speaking for myself right now. I wanted to know what will actually be maybe at a certain point in time that we can appreciate you with, or will there be payment or anything? Because we know you're going through a lot. To have us online and be teaching is not an easy thing. So just wanted to know what will happen that we can actually prepare for it.
Oh,
That
okay.
if it comes up, then we won't be shocked.
Oh, there isn't anything like payment. There isn't anything
Oh,
like payment. But if you want to support maybe bundle and all that, because this is what if you want to support that way, fine. But there isn't anything like payment.
Okay.
Yes.
So say the network is it, are you using Vodafone or MTN?
I use MTN.
so we can
Also,
get your number from the page, right?
Yes.
Okay, that's nice.
Yeah, so we have less than a minute to drop. So I think that we will call it a day, and then whatever comes up, I'll keep you posted in the group.
Okay.
Yes. So thank you for joining, and have a nice evening as well.
Okay.
All right.
thank you. We really
So
appreciate.
have we come to a close?
Yes.